Let's try to solve another projectile motion question. Let you pause the video, read the question, and we'll continue when you're ready. Okay, so where will Tom strike the floor? Let's try to represent Tom with a diagram. So let's say this is Tom. I know that's very accurate. And so he's on a table, and more specifically, he's at the edge of the table. So he's somewhere over there. And then this would be the ground. We know that the table is 1.5 meters high. We know that Tom is traveling with a speed of 5 meters per second in this direction. Since it has a direction, we can say that this is the velocity because it has this direction. So its velocity is 5 meters per second. And we know that based on his trajectory that he's probably going to do something like this. And so he's going to land over here, and we can represent that distance from the edge of the table as this distance d. And so when we look at question A, where will Tom strike the floor? What we're really asking is, what is this distance d? Now, for equations in projectile motion in the x direction, we already know that the equations are quite simple. We know that v is equal to d over t. I'll make that a bit more specific. Vx is equal to dx over t. And if I were to rearrange this for d, which is what we're trying to solve, we know that dx is equal to vx times t. From the question, we already know what vx is, which was 5. So that's great. However, we do not know what the time is. So we have another variable that we do not know, that we need to know to solve the equation. Fortunately though, because this is projectile motion, we know that there is some information in the y direction that we can leverage. We know that the height, so to speak, of the table is 1.5 meters. And we know that when it comes to the y direction, the equations for distance or height are governed by this equation. So we can say d, and I'll just say dy so that there's no confusion. Dy is equal to v naught y times t plus half at squared. V naught is the initial y velocity. Since Tom was only traveling in the x direction to begin with, we know he had no y velocity, so this all goes to 0, and so we're only left with this part. And so we could write that dy is equal to half at squared. Now I can start putting in the numbers of everything that I know in this equation. Dy is just the height, so that would be 1.5 equals half. The acceleration is the acceleration due to gravity, so I can write that as 9.8. Technically this would be negative. I'm just going to omit that because technically by my convention this distance would also be negative if my convention was this, right, over here. But I'm just going to ignore that. I'm just going to keep everything positive because I know that at the end of the day I'm solving for time, and it has to be positive anyways. So 1.5 equals half times 9.8 t squared. Simplifying that, we get this. And so t equals 0.55. So now that we know t, we can go back to our equation. And our equation, just to refresh our memory, was that Vx equals dx times, oops, sorry. Our equation was, just to rearrange that, the same equation, it was that dx equals Vx times t. And so now we have everything we need. We know Vx from the question, it was 5. And we know time, it was 0.55. And so it cancels out. And so we get dx equals 2.75 meters. And that's it. That's the answer to part A. Now, what was part B? Part B was asking what velocity components will he have just before he hits. So that is just another way of asking what is Vx and what is Vy. So Vx is very simple because it actually gave it to us in the question, right? Just to circle it again, Vx is 5 meters per second. And because we are assuming there's no friction, no air resistance, nothing, when it lands here, it's still going to have the same Vx, which is the Vx, yeah, Vx is going to be the same. Vy though is something we do not know. However, we can use the equations in the vertical plane to figure out what Vy is. So Vy is equal to, I should say Vy final is equal to V naught initial plus acceleration times time. We already agreed that this velocity was 0. There was no initial velocity in the y direction. So our equation just reduces to that. We know that the acceleration, once again, is the acceleration due to gravity. Here I have to make sure to actually include it as negative 9.8 meters per second squared, because our convention was something like this. And we already know the time from the previous question. The time it took for the fall was 0.55 seconds. And so, simplifying that, so that reduces to about negative 5.39 meters per second, which I'll simplify and round to minus 5.4 meters per second. And so that's the answer for part B. So that was it. I hope you guys enjoyed that question and learned something. If you had any questions, please post it in the comments below. If not, thanks for watching, and I will see you in another video. Thank you.